All right, so we're going to be talking about Unit 2 now, right? Unit 2. We've been working on the assessment tracker yesterday and today, so you should have done that at the top of Google Classroom. You put in your Unit 1 DEUA, Unit 1 test grade, and I gave you your star if you had it, and your map test grade, right? So your next test will be on the 19th, right? You got 13 days till then. We're going to go over some new stuff. And we'll have 2 tests during the Unit 2 section, okay? Today you wrote assessment tracker on your warm-up, you passed it up, turned it in, your name was on it, everything's great. And now we're looking at these notes, okay? So, do I have everyone's warm-up for the week turned in with your name on it, right? All right, and we're about to go over notes, so no headphones, right? Please, no headphones. All right, let's talk about this. Warm-up sheet. It says, right, assessment tracker. Tracker. Here we go. So everyone has the notes, great. All right, look at this right here. Okay, now in some classes, when you have new vocab, some classes will make you write down everything by hand. Does anyone actually like doing that? It's okay if you do. That's a lot of writing. This could be a lot of writing, okay? And it can hurt your hand. It'd be a lot of writing. And then sometimes it's hard to hear me talk when you're writing to double task, right? Some of us are really just not good at multitasking, right? So all that to say, it's already on here for you, cool? But I'm gonna talk about it, so since you're not writing, you're gonna look and listen. So I'm gonna explain it. But a lot of this should be like, I learned this in middle school already, Mr. G, possibly. But let's go over it anyways. We gotta understand relations and functions. Here we go. First things first, y'all know what a coordinate plane is, right? Coordinate plane looks like this. In fact, there's been one behind me this entire time. Ta-da! Okay, so anyways, coordinate plane is a grid, right? With an X and a Y axis. So, sliding door. Do you know what an X and a Y axis is? Okay, you got to know X is from left to right, horizontal, right? Y axis is up and down, from bottom to top, vertical axis, okay? So we're going to add a few things on here. Yes. Oh, okay, sorry. So we're going to go ahead and draw this. X axis is from left to right, X axis. And the y-axis is from bottom to top, vertical, okay? So horizontal X, vertical Y. You have a little picture off to the right, in case you're wondering which one is which, right? So X is from left to right, Y is up and down. Now, this might be new information. Look right here, quadrants. Quad means 4, right? When you have an X and a Y axis, it makes 4 pieces. Top right, top left, bottom right. And we number them with Roman numerals. Now, intuitively, you might think number 1 would be on the left because we read from left to right, but that's not true. Do you see where number 1 is? It's in the top right section. I need more people looking, or I guess as long as you're looking at your notes, but look right here. Number 1 is in the top right. And then it goes to the left, down, and to the right. 1, 2, 3, 4. Okay? Now, why on earth is 1 on the top right? Here's why. To the right is all the positive numbers, and up is all the positive numbers. So number 1, Roman numeral 1, the first quadrant is where both X and Y are positive. Does that kind of make sense? It's the most positive section. That's number 1. And then you go counterclockwise. Number 2 is the top left, number 3 is the bottom left, and then number 4 is the bottom right. Those are your quadrants. If you ever have a question, just remember, double positive is 1, and it's like you're drawing a C from there. Whee! Next one, origin. Y'all heard that word before? Kind of sounds like original or originate. It's where you start. And where do you start when you graph? But right there in the middle where the axes cross and intersect, 0, 0 is your origin point. Y'all have heard that before? Hopefully. If not, now you know. Origin, 0, 0. Okay? Origin kind of looks like it has a 0 when you spell it. All right, ordered pair is basically when you do x, y. Y'all see that? So anytime you're putting two numbers with a comma, with parentheses that you would graph like a point, that's actually called an ordered pair. That's what the technical name of the numbers with the parentheses and the comma is. Okay. So if you have one ordered pair, that gives you 1 point. That's what an ordered pair is. And then this is going to like kind of go up to the next column. But you got an x coordinate, and then you have to write this in. You have a y coordinate. Okay. And just like the alphabet, it's x before y. Everyone knows x is before y in the alphabet, so the x coordinate is on the left, the y coordinate is on the right. So if I had 12, 7, 12 is my x coordinate, 7 would be my y coordinate. Okay. Next thing, you got to know the different types of graphs. So look at this. Discrete and continuous. I'm going to ask you to draw a picture off to the right here. But look, discrete, underline DIS, discrete, and go ahead and write disconnected. Discrete is disconnected, okay? So if I have a discrete graph that is disconnected, go ahead and draw the coordinate plane, x and y axis, and then you're going to just plot some points that are disconnected, okay? This is what we call discrete, when they're disconnected points, okay? So y'all can draw that little picture next to discrete. Continuous, go ahead and underline CON for continuous. It is connected. Draw yourself another coordinate plane, and you can draw anything that is connected. You can draw a straight line, you can draw a curvy line. As long as it's all connected, that is a continuous graph. Okay? Discrete, disconnected, continuous, connected. Okay? Does everyone see what it looks like on the graph? You got the definition in the middle, got your little mnemonic device to remember it. Okay? All right, next one. What is a relation? Now that word relation sounds like relationship, and it is a relationship between x and y values. It's an ordered pair, ordered pairs, and it's a set. Now look, write this down. A set means it's going to be inside of brackets. You got to use brackets, okay? If you use brackets, like you see off to the right, and you have multiple points, that's going to be a relation. Just a bunch of points. And if you have a bunch of separated points, remember, that's called discrete. So this example is discrete because they're disconnected points. All right. Have y'all heard of domain and range? Maybe, maybe not. Well, you got to know it for sure from now on. So domain is the set of x values. Domain is x, okay? If they're points, you can write those ordered pairs in a relation. It's the x values in the ordered pairs of a relation. Range is y, okay? The set of y values in the ordered pairs of a relation. Now look at the off to the right here. We have the same 3 points as relation. See these 3 points? Same 3 points. But the domain is these 3 x values. This is an x, this is an x, this is an x. Negative 1, 0, 5. Negative 1, 0, 5 is my domain. In brackets. That's what makes it a set of values, okay? Now, the same 3 points for the range, I need the y values. This, and this. These are all y values. So if I write those in order, okay, it's supposed to be in order, it's fine. That's the range. Cool. Usually you'll see those range values in order. It would be like negative 2, 4, 6, least to greatest, but I digress. Okay, that's domain, that's range. Now we have this thing called a mapping. So do you see that little picture off to the right? This is what a mapping is. It's kind of weird. It's like a bubble of numbers, another bubble of numbers with a bunch of arrows, okay? But all you're doing is taking literally the same 3 points as above. You put all the domain on the left bubble. You put all the range on the right bubble. So negative 1, 4, do you see how negative 1 has an arrow from negative 1 to 4? And then 0, 6 has an arrow from 0 going to 6. And then 5, negative 2, starting at 5, going to negative 2. Okay. I want you to notice that these numbers are in order from least to greatest. And the range is from least to greatest. Okay. So again, I would suggest negative 2, 4, 6 in order. Okay. Okay. So we've been talking about domain and range, the x and the y values. You have a mapping. So now you know what when you see that, what does it mean? It's x to y, like a point. X to y, like a point. Now this next part is very, very important. So I want to make sure everyone's looking at me. So look at me, okay? Everyone's here, look at me. Check it out. In math, we have a lot of fun. Chins. That was a joke. Functions, get it? Functions. Y'all don't want to have fun? Chins in math? All right, well, anyways, so check it out. What is a function? Well, it's a relation in which each element of the domain is paired with exactly one element of the range. So what does that mean? Let me tell you. Let's write this down. Ready? Underline first. Each of the domain paired exactly one range. What does that mean? Write it down here. Each x has only one y. This is very, very important. You have to tell me what a function is, and I'm telling you the definition right now, okay? Each x has only one y, okay? All right, so we typically know what functions are in general, right? Think of x as a cool person, and y is like his significant other. It does not function if x does not have only one y. So if an x had two y's, that will not function. No function. Not good. Okay? So look off to the right here. Can y'all circle this? If an x has two y's, not good. Not good. Okay, so we want x to have just one y. Okay. Classic. Understandable. Makes sense. So notice, negative 1, 0, 5. Each of those x's, they don't repeat. They have exactly one y. Everything's cool, okay? So again, for things to function, the input x has to only have one output y. Now, I can give you an example, not a function. You can write this somewhere. 1, 2, 1, 3. Okay? This is like saying One saying 2 is my significant other, but also one is saying 3 is my significant other. Well, that's not going to function. No function. That x repeats, has 2 different y's. It does not work. It does not function. Okay? So again, I see a repeating x. That x has more than one y. Doesn't work. Not a function. That's the rule. Now, we have something called function notation. And basically, instead of y, you can write this thing. Now, how do you say f parentheses x parentheses? How do we really say that? Well, write this down. You say f of x. When I say f of x, I mean f parentheses x. Okay? And what do I mean by f parentheses x? Well, it really just means y. Right? Y is equal to f of x. So why do we need 2 different things that mean the exact same thing? Why do I need f of x if I know it's the same thing as y? Well, here's why. No pun intended. If you look at your next couple of definitions here, when you have something in function notation, f of x, you can replace the x part with an actual number. So look at input. Instead of f of x, now it's f of 4. That means 4 is my input. When we talk about input and output, we like to think of it as a machine. You put something into a machine, some stuff happens, and it spits out something else. There's input, there's output. Go ahead and put above the word input, x. X is your input. You put x into the function, and it results in an output of y. X goes in, y comes out. And what are we plugging it into? But right here, this is my machine, this function right here, 3x minus 8. So if I take 3x minus 8, and my input is 4, that means I'm going to replace this x with a parentheses 4. So 4 is being input. Now you could either use your calculator or do PEMDAS, 3 times 4 minus 8. You end up also getting 4. Now, these don't always match, obviously, but in this case, when you plug in 4 into that function, you end up with another 4. Okay? So your input is 4, your output is 4. Guess what your ordered pair would be? 4, comma 4. Okay? Okay, so just so you know, we're talking about functions this unit. Functions are like a machine. You put an input x, you do the math, you get an output y. Okay? That's what it's all about. Now, when you have a function, or you have something that you're trying to determine, is it a function? Does x repeat? Does x have more than one y? We can test the graph with what's called the vertical line test. Have y'all heard of the vertical line test? Okay, you may have in middle school, but the vertical line test says that any graph, you can draw a bunch of vertical lines, and it says, let's underline here, if a vertical line passes through a relation no more than once, which means once, only once. If your vertical line only goes through it once, then that is a function. Okay, so look at this first little picture. It's a straight line. No matter where I put my vertical line, it's only got to touch it one time. So again, one touch on a vertical line is a function. So look at the second one. See how it looks like an S? I can put a vertical line right here, and it's going to go through that S shape more than once. So think about it. A vertical line means at that X, there's more than one Y. Can X have more than one Y? Not if you want to call it a function. It is not a function if your vertical line touches vertically more than once. So on that example off to the right, it touches it 1, 2, 3 points. That is not a function. Each vertical line can only touch one time, okay? Now, This one's fun. Here we go, real quick. There are 4 words that mean the same exact thing. Look at this. Do y'all see these points that are on the x-axis? What do you call it when a graph intercepts the x-axis? When a graph intercepts the x-axis, you call it an x-intercept. Okay, underline that. I'll finish real quick. Okay. There are 3 other names for an x-intercept that you have to know. So I want you to underline the other 3. What's another name for an x-intercept? Someone tell me right above it. A solution. When I ask you what's the solution of a graph, it's wherever it crosses the x. Another name is a root, and another name for that is a zero. We're going to go over this a lot. You have to know that a zero is the same thing as a root, it's the same thing as a solution, it's the same thing as an x-intercept, okay? Right now, if you don't mind, whether you need to take a picture of it or something, I need y'all to have this down, okay? This, if I can find it, here it is, okay? The other classes, we got through this, and I know we're running out of time, okay? But this is an example of graphing a relation. So if you want to take a picture of it, or I'll upload it before next class, you can get it next class. These are still notes, so no sweat. If you don't get it today, you just want to make sure you get it next class. But number 1, the domain is all the x values, and they don't repeat, right? So here's -3 twice. I just write it once. -2, 1, 3. Those are my x values. And then your y values are -4, 0, 1, 2, 5. You're putting them in order. And then you write all these 5 points in a table. I like to go least to greatest. You put it as a mapping. You put all the x values on the left, all the y values on the right, and you draw arrows. Notice you do not repeat the -3. You only need one of them, but you end up drawing 2 arrows. And if you plot those points, you'll notice that it does not pass the vertical line test right here, right? That is not a function. Okay, so you can plot those points, and you can get down number 1 for me, please, 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 okay? Again, I know we're running out of time, just do what you can, and we'll try to finish off that Monday. Y'all have a great weekend. All right.